Now we have the last type of problem, the mixture problem, the chemistry mixture problem. So none of you know real chemistry yet, but you're going to, so this is kind of a good lead-in, but it really helps to picture this. The key things here is that water is 0% acid. Acid is 100% acid. Now, nothing is really 100% acid. We may say it mathematically, but you really never add 100% acid. That is dangerous. That is stupid. It doesn't exist. It's impossible to get. It's actually even impossible to have, because everything is really some percentage water. Think about all the solutions you liquids that you drink, to urine, to anything. There's always some component of water, and it's usually mostly water. Even the human body is something like 90% water. We're a solution of water. Everything is a solution of water. So 24% acid solution, the first one, that is actually ridiculously heavy in acid and probably very dangerous. So these are not, real examples. These are math examples. Okay, let's move on. You never ever make something more concentrated by adding water. That's dumb. So we'll get to that. But how many liters of water must be added to 20 liters of a 25% acid solution to make a solution that is 8% acid? This is called a dilution. And it's going to follow the same pattern that we did with the grocery problem. We're going to have a rate, but this time the rate is expressed as a percent. And if you think about how percent works, the units stayed the same whenever you multiplied by a percent, and a percent is unitless. But it's still like a rate, so we're going to treat it like a rate. The next one is going to be a volume, and that's going to be the volume. In this case, we're doing liters. And so I'm going to kind of be specific here. We're going to say this is the volume of, I guess I should write this down, the volume of solution, because if I multiply the rate, that's the percent acid that it is, times the volume of the solution, I should get the total volume of acid. How much acid is there actually in the thing? We're going to do this as we kind of walk through this example, but my first row is the 24% acid solution. So the rate is 0.024. I'm actually going to say 24% acid solution, just for the first one. My rate is 2.24. My volume is 20. And then 2.4 times 20 is 4.8. So if you think about it, out of the 20 liters of solution that we have, only 4.8 of that is actually pure acid. And the rest of it's water. But, it's all mixed, so you don't know. Okay, then the next thing I think is the 8% acid, but that's actually the mix. The mix is the 8% acid. That's the last one. 0.08, not 0.8. We don't know anything else about that, so let's get back to that. Because the middle column here that we're adding is just agua, it's water. What's the percent acid in water? We hope it's 0. We don't want any acid in water. What's the volume? That's what we're trying to find out, so that's our unknown, that's our x. We can even multiply. 0 times x is actually 0. So then we're going to add these two to get 20 plus x is going to be the total amount of the mix, because it's going to be 20 plus whatever water we add. And finally, we've become a big fan of this in the last segment, split the cell. This times this is going to be equal to this plus this, and just go ahead and solve. So I have 0.08 times 20 plus x equals 4.8. 0.08 times 20 is, I believe it's 1.6. So that's 1.6 plus 0.08x is equal to 4.8. Subtract 1.6 and I get 0.08x is equal to, that'd be 3.2. And finally, I could do this in my head, and I should do this in my head, 400. Let me just make sure, 3.2 0.08. Sorry, 40. I suck. I know, Gino. You think I do too. Okay, so 40. X is 40. X is the number of liters, so we need W. 40 liters of water. Question answered. Complete sentence. Subject, verb, period, circle, done. Moving along. How many kilograms of water must be evaporated? See, we never add acid. We evaporate. This is not a dilution. This is concentration. And that's how we make things more concentrated. We just let the water go away. How evaporated from 12 kilograms of a 5% salt solution to produce a solution that is 30% salt. So we're starting with a 5% salt. We're not adding anything. We're actually subtracting water. So I'm going to put water here just as a placeholder, and then we're going to end up with 30% salt. We have a rate, and that rate is percent salt. We have not a time, but we have a, let's see, kilograms is a weight. We're now in chemistry, so we're actually going to call that a mass. And that's going to be in kilograms. And then we have, the final would be mass of pure salt. Just like before we had the mass of acid, this is the mass of the salt. That's also in kilograms. Okay, so rate times mass is equal to mass of salt. The 5% salt should be 0.05. The water is 0% salt, and the salt itself, the 30%, is 0.3. Mass. There's a number of ways we can do this. We know that we have 12 kilograms of 5% salt solution. The water, we're not adding water, we're actually subtracting water. That's what evaporation is. And that's going to be what's different about this. I'm actually going to highlight this one. If I can get the little bar thing going, because this is critical to this kind of problem here. It's a little different. We're evaporating water. We've never seen that before. This is new. But we're not adding the mass. We're subtracting. I know you know that makes sense, but you've got to think about if you're going to be able to encounter that on your own. So we get 12. I'm going to put a minus x, or a negative x, because it's really losing it. And then the important thing is that we have 12 minus x for that part. Okay. So what do we do over on the column on the right? So we add, we subtract, it's really kind of irrelevant because 0 times negative x is still 0. 12 times 0.05 is 0.6. Split the column again, or split the cell again. We're going to multiply 0.3 times 12 minus x equals, and take the column over there, and I have 0.6. Okay, 12 times 0.3 is 3.6, minus 0.3x is equal to 0.6. Subtract 3.6 from both sides, and I get negative 0.3x equals negative 3. And that would mean x is equal to 10. Question says, how much water must we let evaporate? We must evaporate 10 kilograms, so we will evaporate 10 kilograms. And this is real. You just kind of leave it out there, you put it on a scale, and when it has lost 10 kilograms, you take it off. Next one. We have 800 milliliters of a juice drink. Okay, we're back to juice drinks, because juice drinks are a lot like chemistry solutions. They're actually the same thing. Just one you can drink and the other one you shouldn't. Let's get pink going. Okay, 800 milliliters of a juice drink is 10% grape juice. How much grape juice should be added to make a drink that is 20% grape juice? Okay, so it's not like the other ones a little bit. We just have grape juice. So we're starting with 10% grape juice. We're adding pure grape juice. How much grape juice? It just says how much grape juice. Don't you hate that? It doesn't say pure grape juice. But that's really going to be 100% grape juice, which is what they're getting at. So we're going to take 10% grape juice. We're going to add 100% grape juice, which is what all grape juice should do. Except it's probably really, really bitter and not fun to drink. I don't know. Not a grape juice person. 10%, 100%. We add to that, and then we end up with a 20% grape juice for our mix. The last row is always our mix. It's not like we're saying 10 plus 100 is 20. What we're saying is we're going to take a certain amount of 10% and a certain amount of the 100% and squish them together so we end up with a 20%. And we want to know how much of each. So, okay. 10% grape juice. We're going to start with the rate. That's going to be percent juice. Then this is going to be the volume in milliliters. And then we have a total volume. And that's in milliliters. Okay, let's do our rates. 0.1, 100% is 1, and 20% is 0.2. Volume. We have 800 milliliters. Oh, don't need to put the milliliters. Wants to know how much we add, so that's our variable. This is our x. And then our final is 800 plus x. Multiply, and I get 80. Multiply, and I get 1x, or x. And then let's do this times this is equal to this. In other words, a split cell. You don't really need to write that anymore because we've been doing it like every single time. 0.2 times 800 plus x equals 80 plus x. 0.2 times 800 is, let's see, that would be 160 plus 0.2x equals 80 plus x. Well, if I subtract 80 from both sides, I get 80 equals, and if I subtract 0.2 from both sides, I get 0.8x. And that would mean x is equal to 100. So this kind of makes sense. We add 100 milliliters of pure grape juice. And there's your complete sentence answer, because that's what the question was going for. Okay, so a chemist. Let's go back to the chemist, guys. Chemist wants to make 55% acid solution. Mix 55% acid with 30% acid to produce 40% acid. So we're going to start with 55% acid. Mix it with 30% acid. And then we're going to produce 40% acid. We have a rate, and that rate is percent acid. We have this is volume in milliliters. And then we have a total volume of acid, and that's also in milliliters. Now the fun starts. We get to plug these in. Okay, so 0.55, 0.3, 0.4. Chemist wishes to mix some amounts of these, and we don't know what they are, so this is probably going to be like our total minus part, and in fact it is. We have 50 milliliters for a total for the mix. Remember, the 40% acid, that's the mix. And then the other one, oh great, battery low. The other one would be maybe a V for volume, and then a 50 minus V. And 0.55 V. 0.3 times 50 is 15, so it's 15 minus 0.3 V. Split the cell. I can do 0.55 V plus 15 minus 0.3 V equals 4 times 50 is 20. Simplify the left and I get 0.25 V. Subtract 15 and I get 5. Multiply both sides by a 4 and I get V is equal to 20. So we must mix 20 milliliters of 55% acid with 30 milliliters of 30% acid. Where'd I get the 30 from? Well, if V is 20, then we have to plug them in each of those spots to get amounts. Okay, last one. Let's see if I can get this done before the battery dies. How many kilograms of pure alcohol must be added to 40 kilograms of a 70% alcohol solution? That could be like our start, to produce 85%, and that could be like our mix. So I have a 70% alcohol. I'm going to add pure alcohol, which is actually impossible. And then I'm going to get, oh, not 830, 85%. And that's our mix. We have a rate, which is percent alcohol. We have a, not a volume, but a mass, which is weird for a liquid, but okay, whatever. Mass in kilograms. Then we have a total mass. So the computer just died. If there's like a little pause, that's why it is. Got it back up. Okay. Total mass would be in kilograms as well. We have 40 kilograms. Oops. That goes here. 40 kilograms. Let's do the rates. 0.7. Pure alcohol is 100%. 1. 0.85. It wants to know how many kilograms of pure alcohol must we add. That can be X, which makes this 40 plus X. Multiply 0.7 times 40 is 2, or not 2.8, 28. 1 times X is X. Split the cell and I get 0.85 times 40 plus X equals 28 plus X. And now we solve. 0.85 times 40, 34 plus 0.85x equals 28 plus x. Subtract 28 from both sides. I get 6 plus 0.85x is equal to x. Subtract 0.85 from both sides and I get 6 is equal to 0.15x. And then we do 6 divided by 0.15, and that gives me 40. X is equal to 40. This makes perfect sense, and I'll tell you why for a reason, but what it says is we must add 40 kilograms of pure alcohol. Now, why does that make perfect sense? Because we started with 70, we added equal parts 70 and 100%, and dead in the middle of 70 and 100 is 85, and that's kind of what we were going for. So, we're done.